Hello, everyone. Welcome back. Announcements. Please do not forget next week, your final exam, 25% of your grade, April 22 during the lecture time. So next week, as I mentioned before, my plan is to do a review in our next lecture, and then the next one will be the exam. Same software that you use for the midterm. I am going to open a link for a sample exam. So basically a link for you to test that your computers work with the lockdown browser. Please, even though you test your computer, your environment, your network before for the midterm, do the test again. Any update in your operating system, any change in your hardware, anything with your network, things happen. So the link is going to open, test your system again. Be sure that you're going to be able to do the exam. April the 22 is 25% of your grade. You do not want to miss that. Similar, you are working in a project. I described the project in the previous lecture. Hopefully everything was clear. So you are working in a project and the project is due April the 20. Please do not forget to submit. It's due midnight, so you have plenty of time. As we discussed before, the new requirements are not a lot. You can finish quickly. If you split the work, you can finish in a couple of days working with your team, or a few team members can finish the project using the full time. Up to you. Remember, one thing is the project, but also I am asking you for additional things to submit. Part of the things that I am going to do today is to describe those additional things. The project, all the requirements in the previous lecture, you can check the video. Everything is there regarding the new things to do for the programming. As I described before, if for any reason you receive a 0 in Spring 2 or 3, because academic integrity, hopefully this is your opportunity to work not only in the requirements, the specification for the new sprint, but also to complete the project that you didn't do before and, well, get some points. The idea, 25% your assignments, so more assignments, small the grade for the individual assignments. So hopefully this helps for those cases in which you get a 0. So do not forget April 22 and April the 20, and that's it. The only thing after that, the grading. So hopefully you're going to have final grades before May the 3. Moving forward, previously I told you about your final project. I showed you this slide. We talk about the requirements for all these things that you have done before. So hopefully this last time, that is going to be perfect. And hopefully this time you're going to get 100 over 100 if you haven't done that before. So it's just the same, the reviews, the retrospective, the board-on chart, the class diagrams, your stories, and obviously your program working. Easy one. Extra to that, I talk about the self-evaluation and the peer evaluations, but also I mentioned to you these two things in blue. That are the two things that I want to describe today. I am asking you for structural metrics, not only regarding the final sprint, but again, I need to be this clear. I am asking for the structural metrics from all your previous sprints. So basically, you're going to submit structural metrics of the different products that you have been submitting, not only the final one, but also the previous ones. And hopefully this is clear. Structural metrics for every single project you submit. Hopefully, yes, the graders, question in the chat, the graders are working in your sprint 3, so hopefully you're going to have feedback soon. If you have a particular question, a specific question, do not hesitate to send an email. But talking about grades, they are working on them. I am going to talk about the metrics. That is something that I am going to share with you right now in the following slides. Obviously, I am not going to ask you to calculate the metrics manually. That could be a little bit boring and a lot of work. So I am going to ask you to use a tool for that. So basically my request is going to be to run the tool 4 times using as an input your 4 different versions of the software. And the tool is going to give you the metrics. My request for you is going to be to analyze the metric, to explain what the metrics mean, but I am going to show you that in the slides. Also, something that I am going to describe is talking about velocity. Velocity is another metric that we have, not for the software, not for the product, but for your process, the agile process that you're following. So using things that you did before, in particular, information that you have in your Bourbon chart, I am going to ask you to calculate your velocity. I am going to give you the equation and an explanation of what is the meaning. So those 2 things are going to be described in my slides today. And those 2 things are things that you are going to add to your submission. Again, even though these things are connected with not only the product that you are doing right now, but with the product that you did before and the process that you have followed before since the first sprint. Good. So talking about the details of these 2 things. Number 1, regarding the metrics. Regarding the metrics, something that I share with you is the tool. The tool that you can use because you are working with Java is this tool called STAN, Structure Analysis for Java. Basically the meaning, if you have the opportunity to access the web page, this web page, you have the opportunity to get the tool. The tool exists in 2 different versions. Number 1, if you are a user of the Eclipse IDE, you can get a plugin that you can add to your environment. And basically the tool is a plugin that is going to run inside of your environment. So far, the plugin exists for the Eclipse IDE. If you are not using Eclipse, if you are not familiar with Eclipse, if you do not want to use Eclipse, there is also the option to download the tool as a desktop application. It's an application itself. It's a Java application. So basically what you're going to have is a jar file. You have an icon, double clicking the icon, and what is going to happen is that icon is just running in the background the jar file. The jar file is going to appear, and you are going to have this Java application with the look and feel of your environment. So you get the tool, you run the tool. I am going to give you a summary of what you are going to be doing, but if by any chance you need more information, specific things, you want to learn more about the tool, I am pointing the link to the manual of the tool. There is a description of everything available there, all the functionalities and all the metrics. I am going to ask you to calculate just a few metrics, the one that we reviewed before, but obviously the tool do more than use the thing that I'm going to ask you to calculate. So the manual and the link to download. So far, I have tested the tool on Mac. If you're going to run this on Windows, I have several students before that have run the tool on Windows, so hopefully still work on Windows. If you are going to use this on Linux, I do not have experience with that, but I will assume that it's going to work using the same way that work in the Mac. So different versions, get the tool, run the tool, read the manual if you want. Hopefully you can just play with the tool. You are expert with the software, so I think you are not going to need to read the manual, but the manual is there. What is going to happen? When you run the tool, and I am going to share you the screenshot of the results, but you're going to notice that there are several metrics there, a lot of metrics. The only ones that I would like you to focus your attention is 1, distance. We talked before about distance, remember? The distance from the line. Distance is connected with this abstractness and instability. You are going to notice that the tool, the stand, is going to give you values for I, A, D. And these are something that we already reviewed. This is something that you already know, right? So other than that, something that is going to happen is that the tool is going to give you the values for these two things. If you remember, in order to calculate instability, what we use is the numbers of lines that go into a class or to a package, and also the number of lines that go out from the class or from the package. In the equations that I show you in my slides, you are going to notice that I use this C out, C in, connections out, connections in. Something that you are going to notice, the tool do not use the word out or in. In the tool, what you have is this and this. Instead of C out, what you have is this CE, CE connection, and instead of out, efferent. For the C in, instead of in, the name, the label that you're going to read is CA for efferent. So use a note in red. Professor, we do not understand what is this CE, CA. Is this C out, C in, connections out. So a common question that I receive, I put this in the slides, I put this in red. Hopefully, remember this. So those are the metrics that you are going to have there. That are the metrics that we reviewed before. And obviously, the tool is going to give you access to this plot in 2D, in which you have abstraction and instability and where is your package or where is your classes. If you only have one package, you can visualize where is your package, the package that includes all your classes, or you can figure out your classes. If you are working with classes, basically you're going to have only one line or another line. Abstraction is going to be 1 or 0. So you use the line or the line. There is not going to be things in the middle of the rectangle, right? So the plot and those values, the tool is going to give you that. More than that, something that you're going to have is a report of things that are wrong. The tool gives you a report of bad things in your design, bad things in your software. Remember, it's a tool that is doing an analysis. So it's going to give you a list of problems, violations, fancy name for it. I want you to review this report. I am going to show you an example and ask you to do something with that. But the report, the plot, the values for the metrics that we reviewed here before, the metrics that you know how to calculate. With that, my question is, for each of your versions, how your project can be improved? You have the numbers, you have the plot, you have a report of problems. I am going to show you the report. So you have this information that you are getting from the tool. What I want you to tell me is, okay, tell me, there is something that you can do to make your Spring 1 or 2 or 3 or 4 better? I am not asking you to do the thing. I am not asking you to fix your code in the Spring 1, 2, 3. The only thing that you are doing, the only request for you to work is new source code for the Spring 4. What I am asking you to do is review your products, check the report in terms of the quality, with the metrics, with the report of violations, with the plot, and write in a paper, in a document, what those metrics mean. What are you understanding for the plot, from the numbers, the errors, and what do you think can be done? Maybe nothing. Maybe there are things that cannot be solved. Maybe there are things in which I have this class or this package in the painful zone and nothing can be done because that package, that class have a particular crazy machine learning algorithm and that one cannot be split. You can explain that. Or maybe yes, maybe in the spring one, you didn't use patterns, and later you learned that maybe that solution can be done in a different way. Or maybe you think about it and say like, well, we put everything inside of one class and the main, and something that we know is that we can do stepwise refinements and split things. I don't know. I am asking you to do a reflection about your understanding of the numbers and probably a proposal about things that you will do better if you have the opportunity to fix things. Again, I am not asking you to fix the things. Do not tell me, Professor, we do not have time. I am not asking you to fix things. Just tell me, what will you do? Because in that way, we know that you understand the report, that you understand, okay, this number 5, 7, 8 means that something is wrong here, and therefore the solution could be this or that. That is our request. So something that you're going to have with the tool is you're going to have, answering the question, you're going to have the metrics, all of the previous ones and more, calculated per package. And when you open the package, you're going to have the metrics, those that apply, calculated per class. So you can imagine these three, and you can imagine the different metrics, and they exist per package, per folder. So you're going to have this abstractness, for instance, for the folder, 0.5. And then when you click, and then inside you have classes. In the same column, you're going to read 1, 0, 1, etc. So for the classes, the abstraction is going to be 1 or 0, but then they are inside of a package, and you're going to have the report for the package. And assuming that you have the same number, you're going to have a 0.5 abstractness for the package. So the tool is going to give you all the information that you need, all the numbers that you need, maybe more. Your goal, my request, is for you to show us in a quick report a couple of paragraphs per project, because again, this is for every single one of your sprints, not only for the last one. So show us that you understand the numbers, what they mean, and what can be done in order to improve. A report that you're going to have is something like this. You are going to select your input, that is your project, the process is going to run, you are going to notice the plots at the center and so on, but you're going to have this report. I just want to show you that the tool is going to give you, for instance, in this example, I have this project from a team 3, and as you can notice, you're going to have the metrics. The metrics include, as I mentioned before, the loops, the distance, etc. And well, obviously others, including this one. Do we understand what is that metric, E-log? Hopefully, yes. Exactly. Something that I would like you to be sure that we understand is those 3 metrics. Everyone is familiar with lines of code. I am assuming the only thing is, are we familiar with the difference between lines of code, log, and effective lines of code, E-log, and logic lines of code, L-log? Just asking to be sure. No? Okay, let me explain that. Okay, guys, in your projects, I didn't ask you for packages. So my understanding for your projects is that you're going to have, most of you, only one package. That is totally fine. I am showing you this example with multiple things just because it's something that I have there from a different class. But for you, your input is one package, and that is totally fine. I am not asking you as a requirement to create more packages. Some of you use packages. I give you feedback. I review some of your diagrams. I review some of your submissions. And I am aware that a few teams are using packages. maybe more packages than the one that you need, that is also fine. Here, I do not review software design with you, so I am trusting in whatever experience you have in software design. So if you have one package, good. If you have multiple packages, good. It doesn't matter. The tool is going to give you a report. The tool is going to tell you what is happening with your package or what is happening with your packages if you have several, and also it's going to tell you what happened with your classes. So you can take advantage of the tool, doesn't matter what you did in your projects. The lines of code, just to be sure, lines of code is every single line, physical line in your programs, every single physical line. So for instance, a crazy example. If I have a method, I am going to use, well, let me do a class, and inside of that class, I am going to put a method. And for whatever reason, I decide to put this curly bracket down, and then I put a comment here, and then I call an instruction, and then I have an if condition here. And I decide to put this curly bracket here, and it's not doing nothing, closing, closing. If I have something crazy like this, and you ask me about how many lines of code do I have, how many lines of code do I have? You're going to say, well, you have this one, and 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 this one, but also this one, and also this one, and this one, and this one. So lines of code. Okay. It's basically how many physical lines the file have. That's it. Yeah, everything. Everything, including those empties. I didn't put those here, but yeah, every single line is literally asking how many lines do you have in the file. It's like writing a Word document, and the number of lines that will report, that is your number of lines of code, just like that. So you can notice the problem with that. I mean, it's like really a line with nothing is counting. And these lines like the 3, 9, and 10, they are counting the same like the others. Lines of code, yes. Now, there are this idea of effective lines of code. Effective lines of code. And you can imagine it like, well, let's count the lines of code, but let's remove or ignore some lines that are not really code, right? Which ones? Number one, the white spaces. Any line that is empty is not going to be counted. Number two, the comments. The comments are not really code, so let's avoid counting the comments. And number three, any open or closing parenthesis or bracket that is alone. So effective lines of code, in my example here, is going to be something like, well, yeah, this one is an effective line of code, and this one is an effective line of code. Oops, this is not going to count, it uses an open bracket. This is not going to count, it's a comment, it's not really code. Oh, this one is going to count, is a line with something. The condition, yeah. Oh, these are not going to count, they are just open and closing brackets. We do not take that in consideration. And well, the same is going to happen with the others. They are just empty, open, and closing brackets. So if we think about effective lines of code, now in this example, I have only 4. So you are going to notice the tool is going to tell you lines of code, the number of lines in your file. In this example, is 10. But then you're going to notice the metric like the ELOC, and it's going to tell you, well, ELOC, effective lines of code, you have only 4 in this particular example. Moreover, the next one, you notice from lines of code to effective lines of code, what we did is to ignore comments, white spaces, and open or closing curly brackets or parentheses that are used alone. They didn't count like code. The other one, you are going to have this metric, logic lines of code. Logic lines of code, to make this easy, logic lines of code are those that are instructions. And how do we know which lines are instructions in a program in Java? Any characteristic of an instruction in a program in Java? Yes, the semicolon. Logic lines of code are going to be those lines that have a semicolon. That's it. So in this program, if the software review, how many logic lines of code do I have? I have only 1. Are you ignoring the declaration of the class, the declaration of the method, and even the if? Yeah. Logic lines of code is like code doing something, is going to be 1. Effective lines of code is going to be 4. Lines of code in general is going to be 10. So you can notice how the numbers go down. And there are different things that we consider. A parenthesis, something that you could be thinking right now is, well, what happens if you have a for loop? If you have a for loop in Java, C, C++, the for loop have semicolon, semicolon. There are 2 semicolons. Are you going to count 2? No. If we have a for loop, even though you have 2 semicolons, that count like 1 because it's 1 instruction. So you count the semicolons in the for loop, but the whiles and the do whiles, the while is not going to count. Yeah, that is true. The do while is going to count. Yeah, that is true. So everything with semicolon count 1. The for loop count only 1, even though you have 2. That is the rule. The goal is to make easy to get the numbers, and the small issues like the do while doesn't matter. Only 1. Answering the question, the for loop is going to count 1, only 1. 1 line, 1 L lock. That is another very good example. It's like now you are thinking like, well, what is going to happen if I have these 2 instructions in 1 line? These 2 for the lines of code is 1. For the effective lines of code is 1, but for the logic lines of code is 2. So the logic lines of code, this metric is going to tell you, hey, that is 2 things, even though you put in the same line. So that example, the one that you have in the chat, 2 things together, 2 instructions together in the same line, that is going to count like 2 lines for the logic. For the others, is 1. Good. So again, remember, these are just numbers that are trying to give you an idea of the complexity of the software. This example, 10 lines, really only 4 are effective, really only 1 thing is happening, or 2 if you want. So that gives you an idea of a lot of garbage in this class. Only 1 thing or 2 things are happening, and you have 10 lines. If you calculate the percentage between the logic and the total of lines, you can have an idea about, okay, this programmer is adding a lot of garbage in the source file. You can have an idea of the quality of the different classes. But well, that is a different story, combining the metrics. But I am describing this just because you're going to have those elements here in the report. In this example, the only one that did mention is effective lines of code. In another report, you're going to have the others probably. Also, I want to be sure that we understand what is this CC. CC is the common literals for what? Metrics about the complexity of a method. CC. Cyclomatic complexity, yes. That is correct. Do we need to learn this for the final? Yes, of course. I mean, I assume that you know this because this is kind of 360. I mean, this is kind of the prerequisite for you to be here. I am explaining the concept just to be sure that if you do not have the prerequisite, then now you have it. But yeah, you can expect this to be in a question in your exam. In particular, the question is going to be like, I give you this report and I am going to ask you, this is good or bad? The numbers. My expectation is that you know that answer for the distance, instability, abstraction, and so on. But we also talk about lines of code inside of methods when you start doing your projects and so on, right? So yeah, take a look to this and be sure that you understand this. Anyway, so you can notice that, for instance, we have the metric, we have the values, and in the report, you're going to have these icons that help you with things that are bad, red, kind of bad, yellow. And in a different report, you're going to have even things in green, like the good things. I'm going to focus with the red and yellow because it's something that you're going to have. And I just want to be sure that we understand things. Why this one is bad? E-log 252. Do we understand why that is bad? Do we notice that the artifact, the element that is listed in the tool is a method? You can review that it's giving us the full path, the package, the class, and the name of the method. So that metric corresponds to a particular method. It's giving us the metric, in this case, effective lines of code that I explained before, and it's giving us the value. The value is 252, and is in red. This icon represents that is bad. Why is bad? Yes, as you mentioned in the chat. Okay, it's a direct message. Well, everyone. Okay, too many lines in a method. Help me. What is the recommendation? Recommendation, because there are not magic numbers. But what is the recommendation for the total number of lines inside of a method? In general, 50 is good. The limit, kind of the threshold that you could consider is 100, kind of, right? So 50, good. 100, you start to get worried about it. More than that, it's going to be an error. So in this case, it's telling you, you know what? You have 252, not lines of code, but effective lines of code. That is less, according with my previous example, not the lines of code. I mean, you have 252 without counting the empty brackets or the comments or the white lines. Without considering that, you have 252, and it's a lot for a method. So you're going to have that. Obviously, I am pretty sure that you remember distance. Notice that this distance, no absolute distance, and the value is -1, -1. We remember what is the meaning of -1 with distance, right? What is -1 in distance? It's obviously kind of worry thing. Yeah, pain some. Notice that this worry, because remember, all these structural metrics this could be a problem. But because we're analyzing the connections or we're analyzing the structure, not really the code, not really the functionality or the logic, the best thing that we can do is to point out something that could be a problem. So you have a method, a class, a package in the pain zone, and it's like, well, that could be a problem. But we cannot say that is wrong. You need to put that out, because we already reviewed that you can have a project, and in your project, probably one class or one package, depending on the size, is going to be there. And sometimes we cannot do anything about it. It's just like, well, it's only one, but there are others outside. Most of the packages of the classes are outside, so you need to balance. So the tool is going to report this kind of metrics with yellow because of that. So it's not like bad, but review. For the method, it's obviously bad because it doesn't matter what your method is doing. Those are lines of code. And if you have a method with 200 lines of code, you can split that into methods, period. There is no reason for having one method with 200 lines of code. Is at least you can have 100 and call another method that have the other 100, or apply a pattern or some other better solution, but you can solve these 200 lines of code in a method. There is no reason for having that mandatory. But for the connection, well, sometimes there is not better solution. Anyway, distance, lines of code, the loop, the tangle thing, and cyclomatic complexity. Again, cyclomatic complexity regarding one particular method, the cyclomatic complexity 17. Help me, what is the threshold for cyclomatic complexity in a method? The value in which we start getting worried about the cyclomatic complexity. Any idea? Yes, that is correct, 10. Any number that is below 10, or sometimes we can agree with the 10, but below 10 is fine. Above 10 start to be problematic. The red zone is 25, like 25 is critical, but above 10 is going to be a yellow symbol here. So this 17 is yellow, like a warning there. Red is going to be until the 25. So in general, cyclomatic complexity, remember, is the number of conditions plus one. The limit that the tool in particular recommend, the limit that you can find in the literature is these 24 conditions, so 25 cyclomatic complexity. That is impossible to handle. That is going to be the red thing. Something between 10 and that is going to be the yellow. Below 10 is not going to be in the report. This one is the name for the metric that is all about the loops. Do you remember? We count how many loops do we have. So in particular for this tool, it's going to give you the percentage of how many connections do you have and how many of those connections are loops. So in this case, it's telling you that only 2% of your connection is loops. Loops could be from one class connected with the same one, or a loop that involved several different classes. It could be two, or it could be something like more of them, but any loop is going to be reported like 1, 1, 1, 1, 1. At the end, it's going to give you the percentage. So that's it. Remember, loops are not like something that you can avoid always. It's a good idea to have a justification for them. Something that we review is, well, this one is needed for the singleton, only if you're doing a singleton. Something like this, usually you can avoid it. We review one example in a class diagram in which you have diamonds, and there are ways to eliminate at least one of them. But again, it's not always possible to eliminate the loop. However, it's a good practice to keep your loops down. So you need to compare how many loops you have, but it's important to consider the size of the project. So that is the reason, because this report as a percentage is, okay, how big is the project, how many connections do you have, and how many are loops. So this one is going to become yellow in 1%. But that is not a particular number in the research. That is more like a decision of the tool. The tool take the decision of these numbers. So it's 1, 2%, lower than 1 is going to ignore the situation. 1 and 2 is going to give you the yellow. Above 2, like this one, is going to put this red thing. But it's more about the tool, a decision that the developers of the tool take, but there is no magic number here. Not like in the cyclomatic complexity or in the lines of code that we have this 25 is the limit or 100 is the limit. This is very tricky because it depends on how many connections you have, and the number of connections is not exactly a representation of the difficulty. You can remember the design patterns. There are patterns with a lot of connections and that do not exactly represent that they are complex. So it's tricky. Use percentage 1 and 2. Good. So you're going to notice a lot of metrics. Some of them we didn't review in this class. Hopefully you're familiar with some of them, like the cyclomatic complexity and the lines of code. Those two are two metrics that you should know because of your background of software engineering. I mean, we are assuming that your background gives you knowledge of lines of code, effective lines of code, logical lines of code, and cyclomatic complexity, that at least you know those metrics and understand the meaning. Other than that, the ones that we review here, distance, abstraction, instability, those are the new ones. And well, you're going to have this kind of report. Obviously, if there are a metric here that you do not know and there is a value here, you do not need to explain that to me. I mean, you can ignore that metric that is unknown by you, that we didn't cover here. You can ignore that in your report. But if you have a report like this and you have these metrics, something that I am asking you to do is, if this is the report of your Spring 1, tell me what is wrong with your Spring 1 and what can you do to improve your Spring 1? I don't know. The explanation could go like, well, we put a lot of things in the init. The init is doing a lot of work. We need to split the init. We need to create more classes. We need to apply view model controller. I don't know. It's depending on what you did. Again, show that you understand this and that you can figure out an idea of what we can do. Good. So the comment for the line. This is about the tool. And again, I show you this, that is the report. Other than that, you're going to have tabs that show you the plot. You're going to have here tabs with more metrics. It's a pretty intuitive tool, similar to your developer environments, similar to any other Eclipse plugin. Any question that you could have, please let us know. I do not want to use the time to explain step by step the tool. I think you can figure out things. But if in any moment you have a question, please do not hesitate to contact us. Yeah, that is a very good point. I am not aware of another tool that is free. So that is the reason because I use this one. And yes, I am aware that it's going to ask you for an older version of the Java virtual machine. I have one used to run the software. So yeah, I know that that is going to happen. I am not aware of other versions. Apologize for that. Yeah, something that happened with Mac users, and I am aware of that, is, you know, security issues and depreciation things. And yeah, you can emulate. You have access to Parallels or VMware. You can install a virtual machine there. I think as a student, you have access to that software. I do not know if that solves the problem, but it could be an option. You can explore others. I haven't searched for other similar tools, but any tool that helps you to calculate structural metrics could be an option. Good. Okay. That one is very, very good. I mean, now that you pointed, that tool is great. I use that tool for other class. If I remember correctly, there is only for Windows. So you're going to need Windows, at least the last time that I asked for that tool. I am worried about the interface. It's a very great tool. It's a tool that gives you a lot of metrics, a lot of results, a lot of great things for analysis. Usually my students complain about is confusing. It's confusing, the full process to start from the project to the metric. So I would recommend that, yes, a lot, but depending on your background, probably you're going to need to get familiar with the tool, and probably you're going to need Windows, not sure. But it's a great tool, yes. Yeah, in fact, in my human-computer interface, I use that one as an example of bad design for the graphical user interface. So yeah, I am familiar with the tool. Anyway, this one, you need Java 6. The other one, great tool. You need to check things. My request is, I want you to talk about the quality of the products that you have developed. I want you to be aware whether or not you develop a product that was good quality or not. And if not, what can you do to improve it? And obviously, I do not want you to be calculating things from scratch. Worst case scenario, if you cannot make any of the tools work, there is always the option to open your class diagram and calculate the metrics manually. At least distance, instability, and abstraction, you know how to do that. Probably I will use my time trying to install the tool instead of calculating things from scratch, but up to you. What I want is you to calculate the metrics and then submit a report about my software was good or not, according with these numbers. I understand the numbers, so I can tell that my numbers are good or not, and if not, what I could do to improve it. That's it. But okay, so that is structural things. Something that you're going to notice, common things that I am assuming you're going to report in your homework and just giving you ideas. Number one, common error. If you try to identify in your software 3 elements, the views, the controllers, and the models, and hopefully we understand that the models are those classes or packages in which you are implementing the functionality. So just try to think about your software and remove, forget a little bit or isolate those classes that are the graphical user interface, those classes that are the panels and the frames and so on. And just think about the classes in which you solve the problems, the classes that have your data, your data structure, the process of things. Those classes in the model view controller pattern, those classes conform what we call your model. Something that is very, very common is to have big, fat models. The classes there, the classes with the functionalities usually have a lot of issues because you put a lot of things in a few classes or a lot of lines in a few methods. That is the description of these big, fat models. Common problem and things that you're going to notice in your submission. Maybe that is one thing. The second, if you think about those classes that implement the listeners, it doesn't matter if you put the listener together with the view, together with the main, or if you create classes separated for the controllers. The controllers are those classes that implement the listeners. The controllers are in your program, in Java, the listeners. Those classes that receive the event from the graphical user interface and then call some action. Something that you're going to notice is these spaghetti controllers. Spaghetti controllers is this idea of one class calling a lot of other classes and sometimes receiving back information from the other classes. You're going to notice what happened with the instability of the classes related with the listeners, with the controllers part. Again, if you forget the views and if you forget the functionality, the classes that are used doing calls to the functionality, your listeners, sometimes they are going to have this problem. Problem in the models, problems in the controllers. And finally, if you review your views, a very common error with the views is this uninjected views. Uninjected. I am talking about these values, these situations in which you have a lot of diamonds, a lot of lines going out from classes that correspond to the views. Instead of having used a normal call, you have diamonds. Then instead of having a normal call and send as a parameter the connection with something else, like I am going to create here an object A, and I am going to create an object B, and I am going to send as a parameter the object A. So I am going to connect these two guys with a parameter. So they exist separate, and they can communicate because one of them have the parameter. The other idea is, instead of this nice thing with everything use lines, I have a diamond with this one, and I have a diamond with this one, but then I am going to have a diamond with this one, and why not another diamond going back? You're going to notice the tangle thing, just because all of them need the other, and all of them are owner of other instead of dependency injection. The loops are going to point you in this direction. So just 3 examples of things that are common things that you're going to notice with the numbers. You can think about if your software is any of the versions in these situations. Lack of dependency injection, mostly in the views. Spaghetti, this bunch of lines going in or out, mostly in the listener classes, or big, fat, a lot of lines of code, high cyclomatic complexity, in use a few parts that usually are going to end in the pain zone also. So for the models, for the controllers, for the views, things for you to pay particular attention. So this is metrics. The other thing that I am asking you to do is calculate your velocity. Velocity, yeah, very, very simple. What you do working with this agile thing is a lot of estimation. You do estimation for each of your activities, for your product backlog items. You remember something that you do is every single backlog item have a priority, but also have an estimation of the complexity. An estimation that is the time that you are going to use to complete that when you are experts or when you have experience, but at least an estimation that is the common agreement of your team about how complex that item could be. Something that you calculate with, among other things, with the planning poker. Hopefully you remember that we reviewed this before. This idea of every single member of the team is going to say a number, the card, the poker. And that number represents how complex I think that particular item is going to be or is, according with my own experience. And basically the estimation for that item is the agreement of the team. It's not a magic number. There is no correct or incorrect answer. It's just the collective idea of the team regarding the complexity, the attention that you need to put in that particular item. That is something that you did in all your sprints. And in particular, you use this for your burn-down chart. That is something that you have been showing in your charts, all the charts that you have submitted. And well, the only thing that I am asking you to do is this part. Velocity. Yeah, velocity is a fancy name for this relationship. How many story points have you completed? So far, you have done 3 sprints. So you can put here a number 3 sprints. And the question is, how many story points have you done so far? I am asking you for how many did you do in the sprint 1, plus how many you did in the 2, plus how many you did in the 3. You have a total, right? You can open your Bourbon chart, check the number that you put there. Obviously, if you get to 0, that is the number. If you didn't get to 0, if you complete less than the number that you put in the axis, use the number that you complete. How many you complete in each of the sprints, the addition, and that divided by 3. And that basically represents how fast you can complete one story point, how fast you can complete one of these items. It should not be so hard, right? You have the numbers, you can do the math, you can calculate this. Now, what you are going to have is this idea of, well, I have a velocity of whatever. And that is a calculation of what you did before. What you did before, I am talking about the 3 sprints that you already run. To be clear, I am asking you to calculate this with the information from sprint 1, 2, and 3. These do not include the 4. The 4 is the one that you are starting right now. I do not want you to wait until you finish the 4 to calculate this. You can calculate this again when you finish, but my request is using 1, 2, and 3, because I want you to compare this with the 4. That is correct. You calculate your velocity, in this case, your velocity using the data from your 3 sprints. That is correct. So the only reason, because I am asking you to calculate this now, and I tell you that you are going to need the information from the other sprints, is because you are going to need those numbers in order to do this thing here, and divided by 3. So you need the information. The velocity is your current velocity as a team. You do not calculate like your velocity in 1 and your velocity in 2 and your velocity in 3, because you do not have information for that. It's just your velocity as a team. I am assuming that you have been working with the same team, but even if not, just calculate this. So the velocity of the team, and we can ignore if you have changed team members. It's not going to be the same, but nothing that we can do. So calculate your velocity using the data from the previous sprints. Now, second, you have the value for the velocity. The next thing is for the sprint 4. For the sprint 4, you know how many points you are estimating the addition of all the points in your sprint 4, right? So you're going to do priorities and the planning poker for your sprint 4. So you're going to have a number of how many points you have for the sprint 4. In fact, you're going to use that for your Bourdon chart in the sprint 4. That number is going to be the number here, the number which you start, right? So I am just curious about it. You have this number, and you have your velocity. If you do a division, if you divided this number by the velocity, you can calculate how many times, how many sprints you need to complete this. Can you compare the reality with these calculations? For instance, imagine that you submit a Bourdon chart for your sprint 1, and in your sprint 1, you told me that you have 60 points. You put that there, and just imagine that you complete everything. And then in your sprint 2, well, sprint 2 was a little bit more challenging, and in your sprint 2, you have 100 things to do, and you complete all of them. And then you have this sprint 3. And in the sprint 3, you also complete everything. Sprint 3 was a little bit more simple, easier, I think. So for your sprint 3, it's like, well, you know what? Hey, whatever. So you have all these things. 3 sprints, you complete everything. You're planning poker, calculate things for 60, 80, 100 tasks. Velocity. Again, you go to your documents for your sprints, review your estimations, and just because you calculate, you finish everything, well, help me to calculate your velocity, and your velocity is, well, whatever you get with the planning poker, your points for the planning poker of the activities in 1, I mean, all the values, and the same for the planning poker in the 2, the same for the planning poker in the 3. So all the estimations that you did for the things that you complete, again, the things that are completed, and you divide it by 3, and you're going to get a number. A number, your velocity. How many story points are you able to complete in a particular amount of time? Let's say that you get, I don't know, a velocity n. Not going to point a number, but okay. The velocity of my team is n stories per sprint. How many stories I can complete in 1 particular sprint. So this is part 1. Part 2 is like, can you do an estimation for your sprint 4? How many story points in your sprint 4? Again, you need to do this because for the sprint 4, you are going to start working, and you are going to define your stories, and you are going to do the prioritization and estimation for your stories. So you're going to get a number about how many points you have in the 4. And I am asking you in particular for this situation in which, if you have this number of estimation for your stories in the sprint 4, can you divide that by your velocity? And that is going to give you a number. That is going to give you a number. And that number is the number of sprints that you need to complete this estimation. Obviously, if you do this correctly, and just because the requirements that I give you for the sprint 4 are very few, what is going to happen is that number is below 1. Worst case scenario is going to be 1 or very close to 1, but it's going to be a small number. Again, if you do the things correctly, right? Because at the end, I am asking you to finish in 1 sprint. But just to be curious here, there is going to be a value. And the value, just because of the division, could be half of a sprint or 25% of a sprint or something. Can you compare this number, the predictions, with the reality? And what is the reality? Well, the reality is, this is the number in which you start. And really, if the number tells you that you can finish in half a sprint, you're going to have something like, if this is the due date, instead of having this line, your reality is going to be like, oh, we finish here. I don't know, just curious about it. I just want you to check what the numbers tell you about your velocity as a team, and have the opportunity to compare that with your last sprint. It's a few sprints. 4 sprints are not enough to really calculate and be confident in the velocity. I understand that. 4 samples is almost nothing, but at least I want to give you the opportunity to compare numbers with reality. And again, I am asking you for the numbers, step 1, step 2, and at the end, 1 paragraph of 2 describing the numbers. I want you to tell me, what do you think about the numbers? Okay, the numbers tell me this and that, and they match with what happened. They didn't match. Maybe they didn't match because you changed your team. So a few members are not there anymore, or because of technical skills, or because of, I don't know. I just want you to do the numbers and have the opportunity to think about the numbers and describe in a few paragraphs, what do you think about the numbers? So understand this. And that's it. That is what I am asking you to do about velocity. Questions? In general, my advice, please, for the spring number 4, do not overthink your estimation. I mean, do not spend extra time, more time than the one that you used before for spring 1, 2, and 3, in order to think about your estimation and somehow look for the numbers to match. That is not going to help at all. I mean, it's not the goal of the exercise. Just do your estimation with the same parameters and the same process that you followed before. If you spend a lot of time thinking about the estimation before, well, do the same now. If that was not the case, if you just estimate quickly without thinking about it before, well, I am asking you to follow the same process now. Whatever you did before, try to replicate with the 4 so the comparison makes sense. In red, there is no reason for increase the numbers, inflate the numbers, and this is maybe a recommendation not only for the project, but in general. Sometimes people think that because we can put the numbers in the 100 lines, that is going to represent that the problem that I am solving is very, very complex, and therefore I am very, very good developer. The problem is that when people notice that you consider complex every single thing, or something that the manager already know that is something very, very simple, they are going to question your technical skills. So just remember, estimation is not an evaluation, but in the long term, if everything is complex for you, for your team, that is not exactly a good idea. So be honest when you do the estimation. And what is going to happen usually is, with experience, your estimations are going to go down, just because now you know how to do things. For this one, same idea, it's a homework, but try to be honest with the numbers that you are reporting. Hopefully the numbers that you report before were honest numbers. So just keep that realistic. It doesn't matter if you put high numbers if your technical skills are low. Well, that happens, you are students, but do not put high numbers if you have good technical knowledge just to justify extra time or do not accomplish the goals or whatever. So careful with the numbers, do the numbers correctly, and that's it. Velocity and the metrics. Any question? Additionally, for the last slide, please, only things that you complete go for the estimation of velocity. If you didn't complete something, as I mentioned before, if your Burdon chart start here, but you do not cross the line of everything done, if you finish here, so just think about having here 100, but you didn't complete this, and maybe this is the 20. Really, what you complete are 80 things, not 100. So when you calculate your velocity, only consider the task that you complete, the story things that you put there that are done. So in this case, only 80, not 100. So that is a common issue, something that could impact your grade, because again, the TAs are going to review these things, the plots. So just be careful to do not include everything if they were not completed. Common mistake. That's it. Good. Any question, guys? Anything? Good. So I am going to stop here. Any question, please do not hesitate to send us an email. See you next week for the review and the exam. Thank you.